So today we're in section 4.6, negative and zero exponents. Negative and zero exponents. So you need to know two things, okay? Your rules for negative exponents say to reverse the sign of the exponent, you write it in the opposite side of the fraction. All right, and you'll see more what that means in just a minute. Yes, your second rule says any number, I'm going to write this one out, or variable, so that part's important, raised to the power of 0 is 1. So that literally means, we'll just throw a couple examples out here. 15 raised to the power of 0, 1. X raised to the power of 0, 1. 30 raised to the power of 0, guess what? 1. Okay? So any number that's not a degree sign, I know it kind of looks like a degree sign, but any number or variable raised to the power of 0 will be 1. And you say, where did the x go? It turned into a 1. Where did the, any variable go? It turned into a 1. All right. All right, example 1. Okay, I'm putting all 6 up there at once, but please do not work ahead. Okay, I want you just to follow along with me and listen to what I'm saying so we can all stay on the same page. All right, so you notice that all 6 of these questions have something in common. They're all whole numbers, right? And what I mean by whole number is they're not in a fraction. Would you agree? Okay, but remember what we talked about at the beginning of the lesson. If it's not in a fraction, I also know that it can be understood that it's over a 1, okay? So if my rule says, let's start here. My directions are going to say, write the expression using positive exponents. That's what it's going to say. Write the expression 10 to the negative third power, so write that in your notes. 10 to the negative third power using positive exponents. Well, I know that it's understood to be over a 1. So my rule says that I can put it in the opposite side of the fraction and reverse the sign. And that really is it, okay? So what I'm doing here is I'm putting the term with the negative exponent in the other side of the fraction, and when I do that, it reverses the sign of the exponent. And that's my answer. So now do the second one. 12 to the negative third power, I want you to rewrite the expression using only positive exponents. So what I do is 12 to the negative third over 1, and guys, that's not even necessary. I'm just writing that so you can visualize that these whole numbers can be made into fractions. And so when I say reverse it, I mean we're putting it into the denominator when it started in the numerator, 1 over 12 to the third. All right, so who got that right? 1 over 12 to the third. And the same rule applies for variables. Okay, x to the negative fourth, I want to write my exponent as positive. I write it in the opposite side of the fraction. I know that it starts in the numerator. It's understood to be over 1. So I'm going to write it 1 over x to the fourth. All right, everybody clear on the first column? Okay, now on the second column, now I have what we know, basically the term for this is a monomial. What does a monomial mean? It means a number multiplied by a variable together in one term. So only one part of this monomial has a negative exponent. Is it the 5 or the b? It's the b. So when I'm writing a monomial using only positive exponents, I can actually split it up. And the only part that I'm going to move into the other side of the fraction is the part with the negative exponent. 5 does not have a negative exponent. Do you agree? So 5 I'm going to leave in my numerator. And I'm only going to move into my denominator. Oops. the part of the term that had the negative exponent. And when I put it in the denominator, my negative exponent goes away. I want you to look at number 5. This is a monomial again. 16 times x to the negative 6 times y, but it's all together as one term. But you don't have to move the entire term to the opposite side of the fraction. What your directions say is write the expression or the monomial using only positive exponents. So the only part of the term that you need to move to the other side of the fraction is the part with the negative exponents. Let's see if you can go ahead and do that. What's important here, guys, is that you understand that 16, that they're all separate, just like I just said. So I can single out just the part of the term that has the negative exponent and drop that one into the denominator. So I leave the 16y up top, and it's over x to the 6th. Okay? I can single out that part of the term that had the negative exponent, drop it into the other side of the fraction, but I leave the other parts the same. If they don't have a negative exponent, I can leave them where they are. All right? Okay, well, here's number 6. We just went over this in the last slide. Something raised to a power of 0 is always something. Okay, so let's see who remembers that. M to the power of 0, n to the negative 4th. I can write it as, good job. What's m to the power of 0? 1. It is 1, n to the negative 4th. So again, we see this situation where not everything in the term has a negative exponent, right? What can I leave up top? 1. The 1. And the n to the 4th moves to the denominator. 1 over n to the 4th. All right, and that's it. What we see in this slide as a whole is that we're moving negative exponents from the numerator down to the denominator. Do you see that? Do you see that common theme? Throughout all of these problems, they all started out as quote-unquote whole numbers, where we move the negative exponent down into the denominator. Well, in the next slide, now you're going to see the negative exponent might already be in the denominator, so now we're going to move it into the numerator. So it doesn't matter what side of the fraction it starts on. If I need to write the exponent as positive, and that's what my directions say, it's to write the expression using positive exponents, I just move it to the other side. It doesn't matter what side it starts on. All right, so I have 1 over 3 to the negative 2nd power, and that becomes 3 to the 2nd power over 1. You see that? But now, get this. Do I need the over 1 part? No. And I prefer that you do not write it. In this specific example, I will not take off for it, but in the next example, it's completely wrong to write a whole number over 1. Okay, and you'll see that in a second. So I would prefer, if it's a whole number, don't put it over 1, just leave it 3 squared. Okay? So now let's look at the next one. We have a to the negative 3rd power over b squared. So again, we have to be mindful of what it's asking us for. It's asking us for only positive exponents. So which exponent is my problem? What? A to the negative 3rd. Is b squared part of the problem? No. B squared is already positive, so it's already met the criteria. So I'm going to leave b squared right where it is in the denominator. But now to make a to the negative 3rd power positive, where does it need to go? Down to the denominator. So what's going to be left up top? If I move a to the negative 3rd down and b squared is staying in the bottom 2, it's going to be an understood 1, because we know that any variable has an understood 1 in front of it. And I've had this question today, well, what if that was a 2, or what if it was a 4? Then great, leave a 2 up there, or leave a 4, okay? But in this case, there's nothing, so I leave an understood 1 on top. And what variable do you think you would write first, the a or the b?
The a.
We always write them in alphabetical order. Remember that for the next couple, okay? A to the 3rd, b squared, and this is my answer. Okay, so in this case, A moved down to the bottom to make it positive, and B stayed where it was. So I've had people trying to put B up in the numerator, but I didn't need to because B was already positive. If I put it in the numerator, make it negative. You see that? Okay, so try number 3. Same concept, it's a little different, but you're writing your answer using only positive exponents. Raise your hand when you have it. Okay, so which variable is the problem? C to the fourth is already positive. C to the fourth, again, my instructions are write your answer using positive exponents. C to the fourth is positive. D to the negative sixth is the one that needs to be moved. Well, it starts in the denominator, so if I'm going to write it in my numerator, I'm going to bring it up to the top. C to the fourth, D to the sixth. I bring it up into the numerator. And again, all I'm left with in the bottom is a 1 now, because I brought D to the sixth up. So that's my answer. So in this one, actually both of my terms were negative. So in order to make X positive, where does it have to go? It's got to go down into the denominator. And in order to make Y positive, where does it need to go? Up into the top. So they actually reverse locations, and it ends up being Y to the third over X to the third. Okay? So again, if I need to reverse the sign, I just move it to the opposite side of the fraction. All right? Y'all with me? Okay. I think that actually went pretty well. All right, so now example 2. Example 2 is completely different than example 1 in many ways, okay? So for example 2, it says to rewrite the fraction without the fraction bar. So I'm not necessarily concerned with only having a positive exponent in my answer. Now, I might, but I might not. I just need to not have a fraction. So this goes back to before the lesson started. Remember we talked about writing a number as a power? Well, in order for this to work, I have to have an exponent in my denominator. Well, 16 to the power of 1 is not going to cut it, okay? I need a number that can be raised to a power to equal 16. Don't say it out loud. Think it. You got it? You got that number? What number can be raised to a power to equal 16? Tell me. 1. Okay, 2 is one of them. 4 to the second power. 4 squared. 4 squared. Is it coming back to you now? So 1 over 4 squared, does everybody agree that's the same thing as 1 over 16? Yes. So now that I have the number written as a power, that's what I've done, I can now get it out of the denominator. 4 to the second power, if I want to put it up in the numerator, that's fine, but it's going to reverse the sign of my exponent. So it's going to be 4 to the negative second power. And now I've gotten rid of my fraction. So I said earlier in example 1 that if on this you put it over 1, it's wrong. Because why? The instructions say write it without the fraction bar. If you put it over 1, you just wrote it with a fraction bar, right? So we're just going to assume, listen, it's a whole number. We know it's over 1, but we're not going to write it. Okay, try the second one. The second one is very similar to the first one. We have to write the number as a power and then get it out of the denominator. Okay, we do that by reversing the sign of our exponent. So now we have 1 over 6 squared, but if I want to get it out of the denominator, I've got to make it 6 to the power of negative 2, or to the negative second power. All right, who got that right? 6 to the negative second power. Who got it right? Julia, did you get it?
Yeah, I meant to put 2, but accidentally copied the same.
Okay, gotcha. All right, so number 3, here's the positive part, or the perk to number 3. The denominator is already an exponent. So on numbers 1 and 2, my denominator was not written as an exponent. I had to do that part. Well, it's already written as an exponent, so there's actually no work for me to show here. All I'm going to do is move my denominator into my numerator, and I do that by doing what to my exponent? Making it the opposite sign. So in this case, yes, I'm making it a negative. Maybe it starts as a negative and then it turns into a positive. But when I move it to the other side of the fraction, I just make it the opposite sign. Does anything happen to my a squared? No. It's already in my numerator. I leave that the exact same. I only change whatever term is in my denominator when I move it up. Okay, so number 4 is a big one. 10,000. I've got to figure out some number that I can write as a power and then get it out of the denominator, just like I did numbers 1 and 2. It's a big number, but the square root is pretty simple to find. All right, I'll give you a minute to work on that. So what's the square root of 10,000? 100 to the second power. So 1 over 100 to the second power equals 100 to the negative second power. When I move it to the numerator, who got it right?
So the thing was,
Who got it right?
way down to 10.
Okay, so what if you did 10? Was it 10 to the what?
Third.
Not third, but fourth. It should have been 10 to the fourth, and then if you did it that way, that would have been fine, 10 to the negative fourth. I would definitely accept that answer. It's just a little harder to come up with those when it's cubed root and the fourth root and all that. Okay? All right, try number 5. Hopefully it's clicking at this point, and but I know it is a little different. So we're going to go over one more, 2y over x to the third. Write it without the fraction bar. So if we have to move x to the third to our numerator, what happens to x to the third? What happens to it? It becomes negative. Okay, so now it's 2x to the negative third y. Okay, now a lot of people said 2y x to the negative third. And while that is acceptable, is that in alphabetical order? It's not, okay? So I prefer this answer, 2x to the negative third y. You just kind of squeeze it up there right in the middle, okay? But when we're moving it from denominator up to the top, in the numerator, we've got to reverse the sign of our exponent. All right, so in example 3 now, we're going to use product of powers. You guys remember me reviewing product of powers at the beginning? Okay, same base. I can add my exponents. No, you don't have to write this down. But you can use the product of powers and quotient of powers property, and now we're going to throw in negatives. Okay? So, this is going to be where we end for today on these 6 examples. Do not work ahead of me. Okay? So we have 5 to the 10th times 5 to the negative 6th. We know that that means 5 to the 10 plus negative 6. You know, I really don't like double signs, but I do want to show you that we are still adding these together, but they are different signs now. One is positive, one is negative. 10 plus negative 6 is the same thing as 10 minus 6. What's 10 minus 6? 4. So this is 5 to the 4th power. 5 to the 4th power. All right, so 3 is my common base to the negative 7 plus 11. Guys, I want this step on your homework. I'm going to take off for it if you don't have it. Please show this step on your homework. Negative 7 plus 11 gives me 3 to the power of 4. So far, when I do my product of powers property, I end up with a positive exponent. That's awesome. That's great. Not so much on the next one. 5 times 5 to the negative 5th power. Well, if there's nothing there, like after the first term, what do I know is understood? It's an understood 1. So when I go 5 to the 1st power plus negative 5, what's 1 plus negative 5? Negative 4. So now I'm going to say that my answer is 5 to the negative 4th power. But my directions will specifically say that I cannot have a negative exponent in my answer, and that I need to write my answer using only positive exponents. So how could I write 5 to the negative 4th using a positive exponent, Amy? I would make it a fraction, 1 over 5 to the 4th. Because technically, this is in the numerator, right? When there's nothing there and it looks like a whole number, I know that it's over 1, understood. So if I need to write it with a positive exponent, I simply flip it. 1 over 5 to the 4th. And here I got another one where I'm raised to the power of 0. So if 13 to the power of 0 is, class? 1. What's 1 times 13 to the 6th?
13 to the 6th.
13 to the 6th. Okay? That's it. So it's just 13 to the 6th. So that one, that can put a smile on your face on your homework assignment if you get one of those, and you can just write the answer. Okay? No problem. Well, write the original problem, then write the answer. All right, number 5. Okay, so we talked specifically just a minute ago, but I think the recording was paused, about the difference between number 5 and number 1. Okay? On number 1, the number specifically was being raised to the power. On number 5, the number is not being raised to the power. What is being raised to the power? The t is being raised to the power. So these, my coefficients, can be multiplied together because I'm not raising them in any powers. I can just do 5 times 3, which gives me what? 15. And now I take t, my common base, and I go -3 plus -8. Go ahead and simplify your answer. And then what'd you get?
Before you put your fraction or after?
Right now, 15t to the what?
15t to the
Negative 11th power. So now, okay, I'm going to give you a shot at it. What's your final answer?
15 over 2 to the 11th power.
You guys are good. Why didn't I move the 15 though? Why did I only move t to the 11th in my denominator?
It doesn't have a negative exponent.
15 did not have a negative exponent. The t did. So the 15 stays on top, and I only move the term that had the negative exponent, t to the 11th. All right, go ahead and do number 6, and we're done. So we get b to the -5 plus -9. What's -5 plus -9?
Negative 14.
B to the -14. Is this my answer?
No.
1 over b to the 14th. 1 over b to the 14th. Who got it right? Okay, good. Very good. And if you understand that, that's everything you need to know for part 1 of section 4.6.